Hi and welcome to my YouTube channel. You are now watching Simple with Engineer Shahinaz and I'm Shahinaz Al-Asrawi. Today I'm gonna explain the OSI model in a simple form. I will tell you about each layer in a couple of sentences, and then I'm going to make videos about each layer separately. So I'm going to make a video about the application layer and then a video about the presentation layer and so on. All the videos are simple but to be specific. Okay, so here we are going to explain why are we using the OSI model and what are the 7 layers of the model, and in a simple form we are going to explain what is the use of each of the 7 layers. So what are the 7 layers of the model and why are we using the OSI reference model? First, the OSI means Open System Interconnection Reference Model. It's a model for referencing. Okay, it's a model for standardization. So, first, what is the difference between standard and proprietary? So here, let me tell you some things. There are words here named standard, okay, versus another word which is proprietary. Okay, what is the difference? Standard means it is something which has standard characteristics. What is a standard characteristic or a standard function? When anything is standard, it means it follows certain rules, so it can work with any other thing which is standard also and follows the same rules. Let me give you an example. Say we are going to talk about TV monitors or laptop screens. Okay, you can find a TV monitor which is 32 inches. You can find a laptop screen which is 17 inches, and there's 19 inches, and there's 15 inches. Okay, so here you can find certain numbers or certain sizes of the laptop screens and the TV monitors. Okay, so why can't you find a laptop with a screen of 17.5 or 16.5? Why is there not a TV monitor which is 33 inches? Is it not possible? No, it's possible. So why is it not there? Because for the TV to work properly and to give you the image you want and give you the resolution you want, and for different movies and different series programs to run on the TV screen and gives you a certain resolution with certain image characteristics, they are done or made to work with certain TV screens with certain sizes. The same goes for a laptop screen. If the laptop screen is 17.5 and the Windows system, for instance, is made for the 17 size, for instance, and certain other sizes, so the image you are going to see will not be fit. It will be not good or not very apparent as you want it to be. So that is standard. When a manufacturer is making a certain product, he makes sure that this product is a standard so it can work with other pieces of products to form a certain whole product in the end. If you are making a computer, so you can buy a computer with a screen from some manufacturer and a keyboard from another one and a mouse from another one and the CPU unit from someone else differently, and the components of the CPU unit is also from other or different manufacturers. So every manufacturer of this one product, which is a computer, is going to manufacture the piece of the product he is responsible for, and he must follow standard rules. So when his product or his piece is attached to the whole product, which is the computer, it can work properly because his piece was standard with standard functions or standard properties. There are another word which is proprietary. Proprietary is something made for a certain product. It can't work with other products. You can find some things which are totally proprietary, like Mac OS. Mac OS can only work with Apple products. It can't work with other products. This is a totally proprietary product. You can find a standard product with proprietary functions. That means this product is very standard, but it has some additional properties which are proprietary. Like, for instance, you can buy a mouse. All computer mouses has two buttons, which are the left click and the right click. Okay, so the left click and the right click are standard properties. In some mouses, you can see a button for, say, volume. You can see a button for light. Anything, I mean, any other non-standard function. Okay, so this additional function is called a proprietary function, which is made for this certain product only. Okay, that's an example just to try to explain why are we making or why are we dealing with the OSI model and what is the relation between these examples and the OSI model and the network. The network you are dealing with has many different devices and applications and functions. You have routers, you have switches, you have cables, you have protocols, applications, encoding, you have signals, so many things involved in the network structure. In order for all of these pieces to fit together, and you must know something, that those pieces do not belong to a single vendor or a single manufacturer. They belong to different companies with different manufacturers from different countries, and in the end they work perfectly with each other. So the OSI model came to make a rule or make some rules, points. If you follow these points, you can make devices and make functions and properties which fit in any network, and you do not deal with certain vendors or certain manufacturers as manufacturers. I deal with the product and its quality, but in the end I do not care who is the vendor of the product, because the piece he is manufacturing is a standard piece which will fit perfectly in my network. Okay, for example, let's start from the beginning here and move to the last layer here, and we are going to explain the layers in a very short form, and then I'm going to make, as I said before, videos for each layer separately. Okay, so what is each layer is made for? Layer 1, which is the physical layer, is the layer responsible for the physical media, which is the cables of the network. It here manages what is the cables that are supported by any network, what is the physical media, what is the signals, the shape of the cables, the speed, the duplex, the functions that are related to the cables. All are discussed here in the physical layer. Okay, the data link layer, which is layer 2, this layer is concerned by the switch and everything switching, the MAC address, Ethernet, serial connections. I do not mean serial cables, because serial cables are here in the physical layer, but serial communication is in the data link layer. Ethernet MAC address is in the data link layer, but Ethernet cable is in the physical layer. Can you relate now? And how the switch learns its addresses, how the switch forwards the data distant to any destination, and how it learns the source of the data from any given source. So everything switching is in the data link layer. The network layer, which is layer 3, by the way, in the exam or in work or anything, you can see people relating the layers with their numbers, not with their names. I can say layer 3 and you must know that I'm talking about the network layer. I do not need to say network layer every time. I can say layer 3 and you must know that I'm talking about the network layer and the router. Okay. The network layer is a layer of the router and routing and choosing the best path from a source to a destination which are not in the same network. The network layer also deals with IP addressing and the logical addressing in the network, and the devices concerned with moving data from a source and a destination using the IP address. It is also responsible for some testing like ping, and we will deal with this later, inshallah. And the network layer is also responsible for choosing the best path or the best route from a source and a destination. Okay, let's start from layer 7 and move downward, because this way you're going to know it better. The application layer is a layer containing the application I'm going to be dealing with in the network. Like, I'm going to browse, make some browsing. I'm going to send an email. I'm going to download. I'm going to upload, chat, remote access. This kind of application. Can you see that it's not the application like the program I'm using? The application layer does not care if I'm using Firefox or Opera or anything with my browsing. It is concerned that I am just browsing, and that's a form of standardization also. I do not care what the browser you are using, I just care that you are browsing. You have in the application layer 1024 well-known applications and other applications for registered applications like, say, WhatsApp, Viber, some things like that, which are not well known or not used by all people. Okay. The presentation layer here is responsible for encoding the traffic, also a form of standardization. You can be sending or receiving any kind of data like voice, pictures, files, browsing, downloading, very different kinds of data. The presentation layer is responsible for encoding all these kinds of data. Encoding means it takes the data in its original form and transforms it to zeros and ones. So whatever the data you are dealing with, the presentation layer is going to transform it to zeros and ones, which is some kind of standardization. At the destination, the presentation layer is responsible for the reverse function, which is decoding. The destination will be receiving some ones and zeros, and the presentation layer is responsible for retransforming those ones and zeros again to the original form of the data, whatever it was, video or voice or text or whatever. Okay. The session layer here is responsible for opening different sessions from a single device to different applications. You can be using a single device, a single laptop, and performing different applications at the same time. You can be browsing, downloading, chatting, and remote accessing at the same time. The session layer is responsible for each one of those sessions, and is responsible for opening, maintaining, and closing each one of those sessions in or with the help of the transport layer. You can see here the layers are helping each other all the way. No layer is working alone. You can't just use the network layer. You can't just use the data link layer. Each layer have a role in the network, and its role is aided with the role of another layer. So the session layer is responsible for opening, maintaining, and closing a session with the help of the transport layer, which decides how my data is going to be treated. I have two kinds of treatment in the transport layer, which are TCP and UDP. I'll explain those in later videos, inshallah. But the transport layer have some kind of treatment, which is TCP, which says that whenever data is transmitted, the destination must tell the receiver must tell the transmitter that the data was received and it was complete and it was with no errors. If any error was received, the receiver must tell the transmitter to retransmit the data again in a correct order and in a correct form. That's TCP, and it's used in applications like download, like browsing, where I need my data to be complete in order and to be with no errors. Another protocol or another treatment in the transport layer, which is the UDP transmission. UDP says that whenever data is transmitted, the receiver does not need to tell the transmitter that the data was received in order or with no error or complete. It takes the data as it is and deals with it as it is. It's not bad or error. It's needed in some applications like video and voice, where I am concerned with the speed of the data, not with the quality of the data, which is not my main concern. I can deal with it, but not through UDP and TCP. That's in a very simple form and very few statements the role of each one of my layers here of the OSI reference model. There's another model which is TCP over IP. All it did was to combine the layers in some layers, like it's a compressed form, but with the same functionalities, like the application, presentation, and session layers are the application layer, where the application layer performs all the functions of the other three layers. The network interface layer here is the data link and physical layer, or the operation and function of both layers. In the course, we are going to explain the full model here, but you can know that this model here is the same as this model here. The model is there at the transmit and is there at the receiver. At transmission, there is an operation called encapsulation, where addresses and other headers are added to the data in order to make its transmission easier and more successful. Okay, when the data is received here by the receiver, the reverse operation is made, which is de-encapsulation, where all the headers that were added are removed and the original data is restored for the receiver here to deal with. So the layers are there from upward to downward at the transmitter with encapsulation, and the reverse operations are done at the receiver from downward to upward. Okay, those are the layers here. Please tell me under the video in your comments what are the videos you are wishing to see in the future, and if you are finding this series useful, and what are the things you want to see differently in here. Also tell me what is the layer you want me to start with, if it's the application or it's the physical, or you want to start from the middle like in the network layer or in the transport layer. It doesn't matter, it's all right. Okay, thank you very much, and thank you for viewing, and good luck.